Right, we have a particles question, so let's have a read through it. A boy throws a ball at a target. At the instant when the ball leaves the boy's hand at the point A, the ball is 2 meters above the horizontal ground and is moving with a speed u, angle alpha. Nice, like the diagram. In the subsequent motion, the highest point reached by the ball is 3 meters above the ground. So we know at that point, if we call it B, that the vertical component of the velocity is going to be 0. So velocity vertical is 0. Target is modelled as being at point T over on the right hand side. As shown in figure 4, the ball is modelled as a particle moving freely under gravity. So we know we've got acceleration going down, we can call that g. Nice. Using the model, show that u squared is equal to 2g over sine squared alpha. So we'll do suvat. So let's start with the vertical. S is going to be, well, going from the 2 to the 1, we'll use this point of B as kind of our final point. So it's going to have got a height of 1. U, the initial velocity. If we think about the triangle over on U, we can think about this as being the hypotenuse. We'll have a horizontal component and a vertical component forming a right angle triangle. So what we're going to have, if we want the vertical component, and this is alpha down here, we want the opposite. So that's going to be sine. So it's going to be u sine alpha. For the final velocity, we know it's going to be 0 because it's not going to be going up anymore at our highest point because it has to change direction, going from up to going down. And the acceleration, we chose up to be positive, so it's going to be minus g. And t, we don't care about. So which suvat equation do we need? We need v squared equals u squared plus 2as. So plugging everything in, 0 is equal to u squared. So u squared sine squared alpha. Because I need some more space for this, so I'll drag it down a little bit. Plus 2as. Well, 2 times 1 times 9 is g. It's going to be minus 2g. So let's add the 2g to the other side. 2g is equal to u squared sine squared alpha. And now we will divide by sine squared. So altogether, u squared is equal to 2g over sine squared alpha. Exactly what they wanted. On to the next bits then. The point T is a horizontal distance of 20. So we know this distance along here is going to be 20. And a height of 0.75. So 0.75 going down and going up. The ball reaches T without hitting the ground, so we know it's not like kind of bounced and come back up again, nothing to do with restitution. Find the size of angle A. So what we can do now is we can set up a similar idea for the suvat. We'll have a look at a horizontal and a vertical components. So horizontal we'll do first because it's a little bit easier because there's no acceleration, so it's just speed, distance and time. So we're going to have our distance s, our speed u, and our time t. We'll say the time is just time because that's going to be then the bridge between the two suvat equations, almost like simultaneous. The distance travelled we got as 20, and the speed we know, well, if the vertical speed was u sine alpha, the horizontal is going to be u cosine. So u cos alpha. So we know then our speed u cos alpha is equal to our distance 20 over our time. So lovely jubbly, we can kind of rearrange that if we want, but we don't know what we need it in yet, like what we want as the subject. So we'll just leave it as that. But that's one equation that we've got. So let's circle that thing. We'll circle this one too. And doing the vertical then, we're actually travelling down. So we'll take down to be positive. So the distance down is going to be from the 2 to the 0.75. So that's 1.25, which I'll write as 5 on 4. Initial speed, it's going up, so it's going to be a negative because we've taken down to be positive, and the u sine alpha. Acceleration, oh sorry, we'll do v first, but we don't know what that is, so we're not too interested. The acceleration then, we've taken down to be positive, so that's g, and t again we'll call time. So here we've got no v, so it's going to be s equals ut plus half at squared. So we'll try and get a nice equation for that. 5 on 4 is equal to u times t, so minus u t sine alpha plus a half at squared. So plus a half of g t squared. Lovely jubbly, we'll circle that, and I think I'll write them all on the next page. So here are the three equations we've got. We're looking for alpha, so I'll write that in the top corner just to remember what we're looking for. And you can see that like this one over here involves u and alpha, This one has u alpha and t, and this one has u alpha and t. So we're going to need to use one of these two on the right, and then replace all the other, like the u and the t, with rearrangements of the other equations. It's probably easier to use this third one, simply because trying to find the values of t using this will be quite difficult. And we can't use this one to find t, so it would have to be this one if we're going to use this as kind of the main equation. So we'll rearrange the middle one to get t as the subject. We'll have t equals 20 over u cos alpha. And actually, if we look at this second term, what we can see is we've got u times t. So if we can rearrange this thing to have ut as a subject, then we can replace that instead of having to do u and t separately. So ut is going to be 20 over cos alpha. So when we sub everything in now, we get the 5 on 4, lovely jubbly, is equal to the minus u times t, so 20 on cos alpha, multiplied by sine alpha, plus a half g, and then t squared. So it's going to be 400 on u squared, we'll just put u squared for a second and then rearrange in a sec, cos squared alpha. So we'll simplify a little bit if we can. We've got 5 on 4 is equal to minus 20. The sine on the cos will give us a tan alpha, plus a half of 400, so that's 200 g on cos squared alpha. And then we've also got this 1 on u squared. So think about what that's going to be. Well, it's going to be sine squared on the top and 2g on the bottom. So simplifying this third term even, 5 on 4 is still the same. Minus 20 tan alpha plus, well, the g will cancel off. The 2 will cancel, but the 200 and the 2 will become 100. And the sine squared on cos squared will become tan squared alpha. And now then what we've got is a quadratic in terms of tan. So we'll set, say, t equals tan and rewrite this. We'll try and make it into not have a fraction as well, just as a bit nicer for numbers. So times in everything by 4. What will we get? Well, we'll have 400 t squared minus 80t minus 5 is equal to 0. And we can divide by 5 to make the numbers a bit nicer. So 80t squared minus 16t minus 1 equals 0. And now then, we'll use quadratic formula. So t is going to be equal to minus b, so 16, plus or minus b squared, so 256 for 16 squared, minus 4 times a times c. So the minus 1 on the c, we'll change that to a positive, and then 4 times 80, which is going to be 320. We'll put that straight in. All square rooted, divided by 2 times a, so 160. 256 plus 320 gives us 576, and the square root of that is 24. Still over 160. If we do the plus or minus, then we have that t is going to be equal to either 40 on 160, or it's going to be equal to minus 8 on 160. So simplifying those, we've got 1/4, or a very small number, minus 1 on 20. Remember now that t was tan, just write this on the left, t is equal to tan alpha. So alpha then is the arctan of these things. And if you look at the path of the motion, it's going to have gone up. So we know that alpha is going to be positive. Do they specify that anywhere? I don't think so. It says it's, right, it does, yeah. Angle alpha above the horizontal. So we know it's going to have to be positive. So we can kind of ignore the negative and just focus on the 1 on 4. So inverse tan of 1 on 4. What's that going to give us? In terms of degrees, 14.036. So 14.0 degrees. Spot on. For C, state one limitation of the model that could affect your answer to part B. If you look through, we've got no air resistance, so that could be one of them. We've also modeled the ball as a particle, so that's going to be a limitation. We've got no spin as well. The ball doesn't spin at all, so it doesn't have any kind of change in its motion via spin. D, find the time taken. So we can use any of the equations really that we've done before. We kind of want to just find T. So it might be easier to sort of use this one. Well, actually this down here. Do we know what U is? No, but we know what alpha is now, so we can find what U is. So let's try and rearrange everything here and see if we can get a nice thing out for t. And give us a little space on this side over here. So let's plug some numbers into this thing and see what pops out. We're going to have t is equal to 20 over u, which when we think about u, we can write this over here. It's root of 2g on sine alpha. Sine alpha, not sine squared. So t 20 over u is going to have a 2g on the bottom, square rooted, and we'll have a sine on the top, and then the cos on the bottom still from the equation over there. So altogether, that's going to make a tan. So we'll have 20 over 2g tan alpha. We know tan alpha was 1/4, so this would be, so that should be root g. 1/4 this, so it's 5 over 2 root g. So altogether, plugging that in the calculator, what does that give us? 5 over square root of 2 times 9.8. Some lovely number, 1.13 to 2 decimal places. Beautiful.